Okay, let me explain limiting reactants. A limiting reactant is simply a reactant in which the chemical reaction limits the amount of product that can be formed. So in other words, the reaction will stop when all of the limiting reactant is consumed. On the other hand, an excess reactant is the reactant in a chemical reaction that remains when a reaction stops because the limiting reactant is consumed. So the excess reactant remains because there's nothing for it to react with. So let's look at something that we're all familiar with, and that is cars. Let's say we're at a car factory. Enjoy my little lovely drawing of a car here. And we have car bodies, and then we have car tires. Okay, so let's say that we have 8 car bodies and we have 48 tires. Okay, if we add these two together, the maximum amount of cars we can make is 8 cars. So we will have 16 excess tires. Because no matter how many tires there are, if there are only 8 car bodies, then only 8 cars can be made. The same is true with chemistry. If there is only a certain amount of one reactant available for a reaction, the reaction must stop when that reactant is consumed, whether or not the other reactant has been used up or not. In other words, we still have tires left over regardless of the fact that we don't have any more car bodies. We still have tires left over. So let's look at an example of this. We're going to say a 2.00 gram sample of ammonia. And if you remember, ammonia is NH3. We're going to say this is mixed with 4.00 grams of oxygen. Oxygen is a diatomic element, so it's got to be O2. Which is the limiting reactant, and how much excess reactant remains after the reaction is stopped? So first thing we need to do is write a balanced equation. Everything hinges on that balanced equation. So we have NH3, and this is a gas, I should write that. And we have O2, which is also a gas, and it's going to yield NO, which is a gas, and water, H2O, but we're going to say that this is in the water vapor form, so it is a gas. In order to balance this, we're going to need 4 NH3s, we're going to need 5 O2s, we're going to need 4 NOs, and we're going to need 6 H2Os. Next, we can use stoichiometry to calculate how much product is produced by each reactant. It does not matter which product is chosen, but the same product must be used for both reactants so that the amounts can be compared. So we're going to say we start off with 2.00 grams of NH3, and we know from our stoichiometry that we are not needing grams of NH3. Instead, we're needing to find grams of NO3 right here. So we're going to multiply that times 1 mole NH3 over 17.0 grams NH3. That's straight from the periodic table. Our grams NH3 is going to cancel with our grams NH3, and that leaves us moles NH3. Still not what we're looking for. So we need to have moles NH3 down here. From stoichiometry, you've learned that this is where your mole to mole ratio goes, so we need moles NO right here. And we actually have 4 moles of both of those. That comes from our balanced equation. So moles NH3 is going to cancel with moles NH3. Next, we're going to look, and we have moles NO. Again, not what we're looking for. So we know that 1 mole of NO equals 30.0. That should be 30.0, not 3.0. Try that again. 30.0 grams NO. So our moles NO3 is going to cancel, our moles NO3. So we have 4 and 4, both of these cancel. We have 2 times 30 divided by 17. This is going to equal 3.53 grams NO. Next, let's take our oxygen. We have 4.00 grams O2. That was given to us in the problem. We know by looking at the periodic table and using our molecular mass, 1 mole O2 equals 32.0 grams O2. So here our grams O2 is going to cancel. We're next going to use our mole-to-mole ratio. We have 4 moles NO for every 5 moles of O2 that is put in. That's from our balanced equation. Moles O2 is going to cancel. And then finally, we have 30.0 grams NO for every mole NO. That's from the periodic table, our molecular mass, our molecular weight. So we have 4 that can cancel with the 32 and make an 8 down here. So we have 4 times 30 divided by 40, 8 times 5. So this is going to equal 3.00 grams NO. The reactant that produces the lesser amount of the product, in this case, our oxygen, right here, is the limiting reactant. So next we need to find the excess reactant. We must calculate how much of the non-limiting reactant, the ammonia, actually did react with the limiting reactant. So to do this, we start with what we know. We know that we have 4, not using the correct pen here. We have, my goodness. Here we go. We have 4.00 grams O2, 1 mole O2 for every 32 grams of O2. Our mole-to-mole ratio, 4 moles NH3 for every 5 moles O2. Next, we're going to multiply it by our molecular mass of NH3. So grams O2 and grams O2 are going to cancel. Moles O2 cancels. We need moles NH3. We know that there's 1 mole NH3 for every 17 grams of NH3. So moles is going to cancel with moles. Again, 4 can cancel with the 32, producing 8. We have 8 times 17 divided by, 4 times 17 divided by 8 times 5. This is going to equal 1.70 grams NH3. We are not done yet. It seems like it's gone on forever, but we're not quite finished. 1.70 is the amount of ammonia that reacted, not what is left over. So to find the excess, we subtract the amount that reacted from the original sample. So our original sample was 2.00 grams of NH3. minus our 1.70 grams of NH3, and that leaves you with 0.30 grams NH3 remaining. If you have any further questions about this, please feel free to email me.